So if you look at what we're trying to do, we still answer the same question. Guys come to you saying, what should I do? Now, you may or may not know exactly what to do, so you go and look at the literature to see what does the literature say about some test. And if you look at the literature and evaluate the literature and read this article, which is written by Ian Chalmers, one of the founders of the Cochrane collaboration, they took studies which have been published in high impact journals and they classified them into two axes. One is relevant to advancing scientific knowledge, that is done for the sake of improving our knowledge about science. And the other axis is relevant to immediate application. Right? And then they found that they could classify them into 4 quadrants. This quadrant they call the Curie Quadrant, which is pure basic science, really trying to only advance frontiers of knowledge. And in the other quadrant you have research which is done for immediate practical application. Right? And then you had a combination of the two. But what they found was 85% of published research will fall into what is called a waste quadrant. It doesn't advance science, nor does it advance research. So the problem you have is when you start looking at the literature, you're going to get all kinds of stuff. Some of them will say something works, it doesn't work, or this test is sensitive or specific. Others will say exactly the opposite. And then the added problem is, how do you know you can trust any of these? So this is our quandary. So if you're looking at the whole field of evidence-informed healthcare, I'm using this term in preference to evidence-based medicine, because it's all about healthcare, and also your evidence can only give you some idea. And you have to think in terms of, I need reliable evidence first. And that you can do if you can find somebody else or some group of people who have taken the trouble to compile everything and give you an impression. So as a clinician, ideally you need somebody else to do all this work and tell you, this is the evidence. And you can read the evidence and see whether you believe it or not, or whether it's applicable to you. And then you can make a decision of, can I use it? In terms of all kinds of things like costs and various other alternatives. Right? So what we are looking at today is this first step, and how can it help the second step? So what we have to realize is that whatever question you are asking, most of the time somebody else has also done something. And we learn because others have done this. And what we need to do is to get a good systematic review of what has been done, which has critically appraised all these studies for quality, effectiveness, or how sensitive, specific it is, and applicability, by pooling the results, so that you get the pooled result from all the studies, if it is possible to do that, and that which will then summarize the findings using a very structured approach called the grade approach. So you have to ask yourself, what is a systematic review? A systematic review is an approach to reviewing studies, where you use scientific principles to first of all make sure you ask the correct question, to make sure you found all the studies, you've got the data and done it in a way that limits bias. And you also look to see how biased are the studies. And then you see whether you can pool the effect estimates from these studies to see, does it help in your diagnosis or in your treatment? And then summarize the findings. So that's a whole approach, right? If you have data in your studies that are similar, that make clinical sense to combine, then you can do a meta-analysis. If they're not very similar and doesn't answer the question from your clinical point of view, don't meta-analyze, right? Now what happens is, because the systematic review is finding different studies, each of them have done it in a slightly different way. So that will give you an opportunity to understand how do these effects differ according to the differences in the way the studies have been done. We are not only looking at the pooled effect estimates. You want to know what are the differences and why are they occurring. If you can explain why they are occurring, you've learnt a lot. If you can't explain why they are occurring, then you are not very sure, and you can't have that much confidence in that pooled estimate. So meta-analysis only talks about one part of a systematic review. So many people will use these two terms interchangeably. They don't mean the same thing. A meta-analysis is a statistical method where you combine the results of several studies. You need at least 2 studies to combine, right? And what you're trying to say is, on average, can I find an average effect? And there are 2 ways of looking at this average effect. The first way is to say all the studies are showing virtually the same thing. then I can say there is one effect. It's called the fixed effect of this intervention or this test for that particular modality, sensitivity or specificity. So I don't have to worry about minor variations in the effect estimates because they're all random, they're all chance. And you can prove it statistically that these are chance variations by a p-value. Right? But if you find that the results of the studies are varying across, the estimate shows something but all the studies are going in different directions, then you got to ask yourself, are the studies actually telling you there is a common effect? There is an average effect. Right? And if there aren't, then you use if you want to still combine the results, you say, okay, I will pool all the results and give you an effect, but that's not a fixed effect. It's a random presentation of these reflexes, and all I'm giving you is the mean of the distribution of effects. Each study is showing slightly different things. This is the range of effects you can get, and I'm giving you a distribution. And the mean of that distribution is all I'm giving you. So it's not a very precise estimate, but give you a common ballpark figure as to what's happening. So you can use the method of meta-analysis to look at incidence, prognosis, prevalence, diagnosis, interventions. But each of them will have different things you have to concern yourself because the primary studies are different. So the way you approach it will be different, and then the analysis is also different, and the software you will also be different. Right? So what you get ultimately is increased power. See, in diagnostic test study, when you're looking at sensitivity and nobody really looks at sample size. But if you know that if you have a very small sample size, your confidence intervals are going to be quite wide, right? And you may get slightly, imprecise estimates because of that. But when you pool the results, because you have a lot more studies, the power increases. So that's the advantage of meta-analysis theoretically in terms of the power, increased power, because small sample size studies don't really matter because they have been pooled with others. The only concern is if you've got a massive study, which is giving you most of the weight for the analysis, then your concern is if that study is not done properly, you're in soup. Because that study is influencing everything else. Right, so the dangers are, you need to do it in the context of a systematic review. Because a systematic review is designed to find all the studies. And a good systematic review takes a lot of time to actually find published and even unpublished studies if possible. Right? Now, why are you interested in that? Sorry? Yeah, so usually what happens is that negative studies tend to be smaller studies and they may not show you conclusive results. You may not be very excited by this. Editors may not be very excited by this. Or even if it does get published, it may get published in a journal which is not easy for you to find because it may not be indexed in a commonly searched database. So what happens is that whenever you find studies easily, you have to ask yourself, is it because these studies are showing positive results, that's why I can find it easily? Because what happens is that they are in index databases, journals accept it. Those databases you search, especially PubMed, because it's free. You're not searching other databases where you have to pay money for. And the degree of overlap in these databases often is not very much. So you are going to get a biased sample of positive studies. So when you pool those effects, what will you get? Positive results. Or results favoring either the test or an intervention. Right? So we have to make sure that we have searched everything, not just a convenient sample which is available. Then we have to keep in mind that every study has a potential for biased results. Right? So if we assess the study and say, okay, I cannot really trust the results, so the pooled result will depend on all these biases being there or not. So we need to have some understanding is, can I really say this is the true estimate from the way the studies are done? Whether it's an intervention or a diagnostic study, the same principles apply. You have to look to see how likely is the methodology of the study is influencing the result. Okay. Then you have to ask yourself, I see that the studies are not consistent. But hang on, is it possible that in a subset of the study which looked at this particular thing, the results are consistent? And in another subset which didn't look at that but looked at something else, the results are consistent. Like older people, younger people, more severe, yes severe, different thresholds for a cutoff point. Within those thresholds, they're all showing similarities. Then I've learned at this specificity or this threshold, this is the specificity and sensitivity. And a different threshold is something different. Okay, so these are the three things that we need to keep in mind when you're trying to do a meta-analysis. Have we missed out studies? have we neglected to incorporate the studies? Now finally what you have to do is, you have to give us an estimate which incorporates the numerical values as well as the confidence that you can say this numerical value is likely to be the truth and you're likely to get it if you use the test. So that's what we're going to see how we can do that. Before I do that, just run you through what is the difference between a review article that you commonly read and a systematic review. So a review article has got many purposes, but systematic reviews are very focused. And for narrative reviews particularly, it's a PICO, that is population intervention comparison outcome. In this group of people, will this drug versus that give you these outcomes? That's what you're looking at. The other more important thing is systematic reviews are supposed to have a protocol, which is a methods section. Whereas traditional review articles don't have a methods section. So you don't know how they did, why they did, what they did. It cannot be reproduced, right? It's just an opinion piece from that point of view. The other thing is that systematic reviews are designed to maximize the what can I say, the expertise of the team that's doing it. So ideally you need somebody who understands that condition or disease and somebody who understands the methods of synthesis. Right? And sometimes you may also want to consider, especially in intervention trials, the people who are likely to use it, like the consumer, patient groups. So there are many systematic reviews which include patient groups to ask the group to think in terms of what is important for patients. That will determine what kind of outcomes you are choosing. Now keep in mind, when you're doing a review article, you're just reporting what is reported. When you're doing a systematic review, you're asking a research question. And therefore you have to make a decision as to what kind of outcomes you want. Right? Whereas if you're doing a review article, you're reporting so many people reported this. Okay, so that's the reason why it's important to have a good mix. And knowing well that interventions as well as tests have got a lot of commercial potential, as well as academic, claims. I have been in a guideline committee where the people who wanted their test to be included have patents on that test. So that's clearly a conflict of interest. Then you have reviews being done by authors who have done either the trials or the diagnostic studies. So they will influence what the results are unless you're very careful to make sure their opinion on that test we will ignore completely. Unless we have doubts about methodology, we won't bother about what he says. Whoever he is, senior person, I don't care. You don't influence this test. And the other thing to keep in mind is that, at least for systematic reviews of interventions, there are standards for reporting the primary studies like CONSORT, and there are standards for reporting systematic reviews of this, whether it's observational study or a trial. There are systematic review guidelines and reporting standards, right? Then, when you're selecting studies, a systematic review is supposed to have a very clear, detailed list of which are the studies we're going to include, what kind of studies, what kind of participants, what kind of interventions, a very detailed list, which you may probably not find in a review article in that detail. And the search strategy is quite detailed. I'll show you all the databases people search for a systematic review. And you're ideally expected to be very transparent about it. And Cochrane has from the beginning been an online platform. So the word limits are quite different from what you find in a journal article. So regular Cochrane reviews can be 300 pages long because of all these appendices and things of that sort. Right? And each time you select or exclude a study, you've got to give a reason why you did that. And you provide a list of all the excluded studies with the reasons for exclusion as well, which you're not going to find in a regular article. So what may surprise you sometimes when you're reading a review is, you will see a study that you recognize as very influential in your field has been excluded from this review because it is just an observational study, which is what had been guiding practice for so long. And in a systematic review, in the protocol itself, there will be a section which says, how are we going to assess risk of bias in these studies? Right? And the results should show you the results of the risk of bias assessments. And there's a very detailed section on how do you plan to combine the data and how do you plan to use it for subgroups and stuff. And then finally, you'll find that the way in which this review is done is that it is independently done by at least two people, so that the biases of each person can be balanced out and mistakes can be identified. And then you need to have a way in which you can resolve disagreements. And then when you're looking at the results, regularly what you look at the numerical value and you will think that is the truth. But a systematic view just says reviews of the numerical results are only one part of it. It will combine it with measures of whether the study is well done, are the inclusion-exclusion criteria likely to be directly applicable to clinical practice, what is the real importance of these outcomes, are they just statistical significance or will you actually use these outcomes because they're clinically useful, and also are the results consistent. So there are criteria by which you can say, I have a lot of confidence in the result. And we'll go through those criteria. How do you make that decision? And then when you make a result of a systematic review, generally you don't make recommendations. Because the recommendations are meant to be made by guideline developers or policy makers, or the people who want to, frame a policy of use. You just say these are the findings, these are the implications. Because the thing is that up to now, you're looking at all the evidence and looking at the risk of bias and stuff. You're an expert in that. Then you start going into the realm of conjecture, where other people are going to use those results. You don't know. So you can give them some guidance, but you cannot give them a final recommendation. And systematic reviews, particularly the Cochrane ones, tend to get updated when you find new studies. But even Cochrane is now coming to the phase where they say, okay, we are not going to update anymore. Why? Sometimes it's because they have enough evidence. They don't think any new trial is necessary in that area. And there are criteria by which you can come to that conclusion. Sometimes it's because they find that people's interests have gone. They've shifted from this to something else. So this is no longer a relevant area. So let's not keep updating this. Let's not waste our time on that. But in a systematic review, if you are doing it with a team like Cochrane or some of the other agencies which support reviews, you get a lot of help from them, because either if you get funding, you may be able to hire people to help you do the search, because sometimes you end up with 25,000 articles you have to search through. Right, so it depends on the kind of resources you need. Cochrane gives you resources in terms of a good editorial team, which very often has search specialists, information specialists, who will help you with the search strategy, who will run the search, find the studies for you and send it to you. Of late, that's what they all do. But if you don't have that team, you need the money to search databases where, sometimes you won't have access to. Or at least you need to have friends in countries where they have free access. You need to use either your ingenuity or you need to have money. Anyway, the overall impact of a review article, a regular review article, depends on who wrote it. You can ask yourself in your field, written by this person, everybody will use it. Whether or not it is the truth is not the issue, because that's an influential person's point of view. So there's something called an invisible college, right? That college dictates what goes on in any of these places, right? So in general, what to look for in a systematic review, you need to know what is a question, is it clearly defined, and ask yourself, is that question what I'm interested in, including the way they framed it, and assess to see whether they've really searched properly. Is it likely they missed some studies? Then look at what their inclusion-exclusion criteria for getting the studies in, because that will tell you whether it's ultimately applicable to you. Whether the studies exclude or include things that you're not interested in, it may not be directly. And have they given you a good list of whether there are many more studies? Because sometimes you'll find there are a lot of ongoing studies. And although the review does not tell you an answer, you know there are at least 15 other studies. You just have to wait a little bit for the updated version. And that may prevent you from going and doing a study yourself, because you say, let me wait and see what the other studies have shown. Right? Then you have to see whether they have done a good assessment of risk of bias and what instrument they use, because there are many instruments that people use in risk of bias. And people now realize that many of them don't actually do a good job. And many of the numerical scores they give you are not really validated. So you'll have to look at that. Then you look and see whether the way they extracted the data, they are likely to have done a good job, and how they did the analysis in terms of did they look for differences in the studies and explain it, or did they do different analysis? Suppose they change the threshold, what would have happened? So have they done a reasonable, intelligent way of looking at the data, or is just one way of pooling stuff together? And then you can see whether they've discussed their own limitations and strength of the evidence, and finally look for the summary of findings, where they have linked the results with the confidence that they can have in the results. That will give you an idea about how it will help you in your patient care or future research. Now, if you look at the difference between intervention reviews and systematic diagnostic reviews, and you look at these steps in terms of asking the question, acquiring the results, assessing what you got, analyzing it and reporting it, there are clear differences. First, in asking and making the questions, in systematic reviews of interventions, we use the PICO, P-I-C-O. You can also say it's PICO for diagnostic tests, but ideally you need to break that up a little bit more to make sure what you get, and I'll tell you how you can do that. The second thing is, when you're searching for a randomized trial, you can put a filter for RCTs, and you can search by the intervention, this drug, right, and the condition, and you'll get most of your studies. Whereas in searching for diagnostic studies, it's quite difficult to search because indexing has not been that good. People label the studies in different ways. Increasingly, it's getting better, so you might need to start using terms like sensitivity, specificity, those measures, and then combining it with the name of your particular condition or the test that you're doing. So it's a little bit more complicated to actually do a good search for diagnostic test accuracies. And there is no real filter that any software has, search engine has, for searching only for diagnostic test accuracies. It'll probably come, but it's not that there. Then the other thing is, when you're looking at risk of bias, the instruments you use are quite different. In intervention review, you use currently we use what's called the Cochrane risk of bias tool, assessing risk of bias in selection, performance detection, outcome detection, and selective reporting. Whereas here, we tend to use the QUADAS tool. Now, you are familiar with the QUADAS tool, and you can see how we can apply that in a systematic review. Then we are looking at what data you're extracting. In an intervention review, it's a number of people in each of the arms who got the treatment. Either it will be in terms of the outcome, or it will be in terms of the scale used or the continuous variable you used. Here, you're extracting data to fit your 2x2 table of sensitivity and specificity. False positive, false negative. So the amount data you take is very simple, but there are differences in that. If you want to look at an overall absolute measure in an intervention review, you tend to look at the number needed to treat. Whereas here, you can look at that single measure, you can look at diagnostic odds ratio, which is a ratio of likelihood ratio, positive over negative. Right? The chances of getting a positive test over a negative test in a particular person. And when you're looking at the forest plots, I don't know how many of you have seen forest plots for a systematic review. It's basically a series of lines, but it's only one plot because that's one outcome. Right? Here, you've got sensitivity, specificity. So you can either have two sets of plots coupled, which shows sensitivity, specificities, or you can do it as a kind of a summary receiver operator characteristic curve. And you can see how those go. Then when you're looking at heterogeneity to see how the results vary between studies, in an intervention review, you tend to look at what is called the I-square. So you're looking to see whether the studies overlap in their confidence intervals, and there is a chi-square test to say whether this variation in the results can be explained by chance. And there's a p-value for that. If that p-value says that no, this is not due to chance, you have another statistic which tells you what proportion of these variation exceeds what chance will tell you. So if you get an I-square, something like say 75, it means only 25% of the variation in the results in these studies is due to chance. 75% of it is due to something else in those studies. That tells you they're not common. They're not giving you the same result. In this diagnostic tests, you don't have a single measure like an I-square, but you can use these summary ROC curves in a bivariate analysis, which will look at what is the credible confidence interval for those studies and project from that a prediction interval, which is like saying how much heterogeneity will you get in terms of predicting what will happen. There will be a much wider range of the thing. So it's not a very precise measure like an I-square is. It's a kind of an assumed measure. You'll have to make a decision based on the graph. And then in systematic reviews, when you have trials looking at the same thing, the results all tend to be similar, the methods are similar. you get what is called a homogeneous group of, they are all very similar. Your I-square will not be very high. So you're assuming there's a fixed effects model. Now earlier on when diagnostic test reviews were being combined, they were using a model called the Moses-Littenberg test. But they have discovered that's not very good when you have heterogeneous models. So now for heterogeneous model, they have a lot of these hierarchical models, very complicated to do, but they can be used to deal with the heterogeneity in studies. When you're looking at the reports, primary studies, we tend to see how well the reporting is done in interventions by consort, where here we use STAR-D, and we don't have an equivalent to PRISMA for diagnostic test accuracy review. So there is no official guidance. The only thing I can tell you is to look at the Cochrane handbook for diagnostic test accuracy. You can get that online, and I can give it to you, which has got chapters for assessing risk of bias, for pooling results, and for looking at the overall body of evidence. But that's not been internationally recognized as a single standard. It's just a guidance book. So if you look at meta-analysis in DTA reviews, the idea is that you want to provide an estimate of the average diagnostic accuracy of tests, the uncertainty of this average, and the variability of the studies. That's what you're trying to say. What is the average diagnostic accuracy for the two measures of sensitivity and specificity, and the confidence interval for those, and how variable are the results across the studies. And you can compare accuracy of two or more diagnostic tests and describe how the accuracy can vary with different thresholds and other different categories. Okay. So meta-analysis helps to make use of all these differences, because you can look at the study characteristics and say, can I account for these differences based on that? So what happens is that when you have a larger amount of data, you may actually be able to find some kind of conclusive answer which you could not do because you didn't have the precision in previous studies. And you can also look and say, why are results inconsistent? So the same reasons what you're going for interventions, you can apply that to diagnostic test accuracies. And you can even do a lot of modeling frameworks for using meta-analysis. So in an intervention review, this is your question. Patients, interventions, comparisons, outcome, time points, or study designs. You can adapt that, but we can also change it slightly different to widen what you're trying to do. So you have just not one P but three Ps, but it all comes under that patient. But here you're saying, I need to be able to have some idea about the patient characteristics and what their symptoms were, to say whether they're sick or what was the stage of illness they are in, and whether they've had any prior tests. Because a person coming for the first time is slightly different from a person coming after having been proven positive by another test. So in tests, either it's a clinical examination or they've already done a screening test and come to you. So you need to know that. Right? The second thing is, you need to know what is the index test and the comparator test if you're comparing two tests. And then what is the purpose you're doing this for? I'll give you an idea of what that means. It's important to know what is the purpose. The next thing is you need to know what exactly is the target disorder or condition and what is your reference standard if you're using a reference standard. We don't use the word gold standard because we know there's no gold. So if you look at purpose, your purpose could be that you're doing a test to replace another test. So that's one of the purposes of doing a thing. Or you could be doing it for triage. You're doing a comparator to see that if those who test positive, in order to get more accuracy, we are doing another test. Okay, using an existing test to see which can I get more positive results, be sure of the result, like a confirmatory test. Or you can do it in the way that as an add-on to see whether in the people who are negative, can I reduce false negative rates? So using that in combination. So keeping this in mind, when you're framing your question or looking at a review, you need to know what exactly was the purpose of this review. And then of course, as I said, you can look at diagnostic accuracy of a single test, or you can also look at how they affect patient outcomes. Right, so diagnostic tests, reviews can look at both of these angles. So you need to have a statement of purpose or your aims. And it will be either, for example, should test A versus test B be used in some patient or a population, or should test A versus test B be used for some purpose? For example, this could be a statement. In patients suspected of coronary artery disease, should multi-slice spiral computer CT of coronary arteries be used as a replacement for conventional invasive coronary angiography? to lower complications with acceptable rates of false negatives associated with coronary events and false positives leading to unnecessary treatment and complications. So this is a full aim, what exactly the person is trying to do in this test. So you can look at it like this. You can have RCTs that are exploring a diagnostic strategy by a particular thing designed as an add-on to diagnose heart failure compared to no use of this natriuretic peptides. Basically, you can either do it as a cohort study where you use both the tests, or you can even randomize people to both these studies. And then you're looking at the true positives, true negatives, false positives, false negatives in each of these. And then management decisions can be made. And you can even go down to seeing later on what are the outcomes in that. So that could be one way systematic reviews are done. We're looking at all of this or only part of it. The other thing you can look and say is, it's a standard target population where you have a new test versus a reference test, the standard diagnostic test accuracy. But in this kind of situation, for example, non-contrast helical CT compared with intravenous pyelography in the diagnosis of suspected acute urolithiasis. So what happens is when you do this comparisons, the stones in the urethra that the CT detects may not be picked up by the other one because that's much smaller, right? And so they'll pass away more easily, right? So what you will then find is that when you're looking at intravenous pyelography, you'll have to actually do an RCT to make sure that the false negatives are out there. So sometimes from this itself, my design may have to change if I want to answer this question properly. Okay. So Madhukar Pai's got a nice little article where he describes a roadmap for systematic reviews. So he starts out by saying you've got your PICO, whatever. Then you've got to make sure you look at all the guidelines and other studies so that you can have some idea as to what my protocol should look like. Why am I doing this? What are the important things to study? So your background section. Then you got to decide, okay, where am I likely to find all these studies, and you define your search strategy. So the recommendation for these diagnostic tests is that apart from PubMed, Embase, Biosys, Web of Science, there's a database called MedDion, which looks at diagnostic tests. So that may give you a higher search yield for diagnostic test studies. And then you can look for AIDS, for example, there are databases for AIDS tests. Then you also have to expand that by looking at other, for example, the companies that make the test, they may have some data on that. Or if it's a company that makes a drug, they will have data on that. Similarly, there could be some experts you can contact and find out from them what they know. Do they know of any additional tests? Then you look at all the cross-references and see have I made. So it's multiple sources to make sure you get all the studies that you want. And you can do this either using a reference manager software, which can help you both find the studies as well as manage the search. Because if you use one of those reference manager softwares, you can look at all the studies and then looking at their abstracts, decide whether they're excluded, and you can even make a note of why are they excluded. So it'll help you when you're doing a review. Or you can use the many software helps you even do all the searching, right? There is a software which Cochrane now does once you get all the studies, which helps you to manage all this literature. We'll talk about that later. So then you run the searches, and after you use all the software, the one that, it's easiest thing to use, there's a free software called Zotero, which can be used to manage references. It's absolutely, the rest of them you've got to pay for it. Or you'll have to use a pirate copy. I didn't say that. Then there are certain search filters, ready-made filters you can find online for the basic diagnostic test studies. So some of the time you can just copy and paste those search filters into this. And once you got your documents in Reference Manager, if you don't use Reference Manager, at least in folders, which are saying full search results, and these are excluded studies, these are included studies, making sure you don't make mistakes about things of that sort. Then the next thing is you need to ideally have two people who will screen all the abstracts and then make a decision on should I include or exclude, right? Ideally, it'll be good that somebody else screens all the studies they've included and a proportion study they excluded to make sure they've not made mistakes in that. The other option is each reviewer screens everything and they compare their decisions in terms of you have excluded this, but I think this is the reason why you should include it, and have a decision on that. And again, these reference manager software will help you. Then once you've got a decision as to how many of these studies are definitely included and possibly included but not sure, then you move from the abstracts to go and getting the full text. So you don't get full text articles for everything that you find. Only the ones that you are sure you want to include by your PICO or your other way of looking at it, or where you're unsure and you need to read more than the abstract just to get everything. And once you've got all that, you start looking at a log and saying, okay, I've got, in my review, I wanted to compare this test versus that test. And I also wanted to compare this versus another test. So if you've got those things, then you've got to start thinking in terms of classifying which of these aims am I actually addressing. So you start looking at studies which are looking at this particular aim and the other particular aim separately, or sometimes studies look at both. They look at both together. You've got to classify them very carefully. So why it's called a systematic review. You have to be extremely systematic in the way you approach this. And finally, each study gets a particular ID, and each reviewer will have a different way of how do you index those studies. Then the two people, at least two people, extract the data that you want. And what data? Ideally, you need a data extraction sheet, which will tell you what all you want to extract from that. Not just the numerical data, a lot more data. So once you've extracted the data for your sheet in terms of what all you want to extract, which will give you an idea as to what exactly was done, who were involved, what were the tests used, what was the details of the test. And then you also want to ask yourself, is there a risk of bias in this? Get all the data to assess that. So once you've done all that, then you start extracting the numerical data, true positive, true negative data. Not till then. Okay? And then once you enter the data into your, what happens is that you can extract all these data into an Excel or an Access sheet, or even just Word documents. But generally, the software you use in Cochrane is not, most analysis is not the review manager software, except for very simple ones. You got to use other software like SAS or MetaDisk or MetaTest or Stata to do all these complicated analysis, but then you can import it back into RevMan for the figures, graphs, and things of that sort. So there are suggestions on what kind of data analysis you can do. And when you're writing up your review and doing the grade analysis and stuff, since there is no data for, no reporting standards for systematic reviews, at least you can use the systematic reviews for observational studies, because these are all observational studies. They're cross-sectional studies or they're cohort studies. So using that basic framework, you can start writing up the design relevance. So let's just take one review. This is Expert MTB RIF and Expert MTB RIF Ultra. That's a more sensitive test for pulmonary tuberculosis. A very recent review. It's an update of a previous review. And there was a previous review done in 2014. This is an updated version of this.
One of these studies they did for their...
Yeah, I know they did. So I'm just going through this because you know what the study is about, right? So since you're familiar with it, it'll be easier for you to understand this. Right, so that's the background. Now, does anybody have any idea, anything more in the background? You read the review, no? So in the background, they give you a lot of reasons which will help you to understand why they did what they did. So for one, you will find the clinical pathway, how a test can be used. So in the background section of the review, you will find this ways in which expert is used and for resistance and what will happen. So any review that you're doing, you're supposed to have a kind of a logic framework as to how is this review going to be used. Then you can decide which aspects of these reviews am I going to attend, right? And they also try and tell you, okay, you're making a diagnosis of the outcome. What is resistance going to look like? So they tell you very clearly when you're doing this gene expert, your results are positive or negative. It's dichotomous, right? But when you do ultra, they give you a range. So then you've got to make a decision, how am I going to interpret these ranges? Detectable, will I say it is there or not? So the idea is you're refining what you consider as a positive or a negative diagnosis, which is not a problem for gene expert because it tells you yes or no, right? So the objectives were to look at the diagnostic accuracy of expert and expert ultra for tuberculosis in people with presumptive TB and for rifampicin resistance. And secondary objectives is to compare the two and also look for heterogeneity in groups of people. So heterogeneity here, they're looking at covariates. in terms of detection of PTB, HIV status, tuberculosis, history. So they're making an idea in the beginning. I expect to find the results may differ because these are potential confounders. HIV positive or HIV negative. These are confounders for these differences. So, and the ultra gives you slightly more amplification targets, and you can get a slightly larger DNA cluster. So the kind of studies they looked at, what kind of studies would you look at, will you include in this, if you're looking at expert TB? Off the cuff of your head, I'm looking at comparing expert TB in people with TB. What design will you look at? So you're going to look at case control. Now, what would be the problem if you use a case control study? You're likely to get a lot of spectrum bias and various other verification bias you get. So you've got to decide in advance what design do I want if I want a good answer. So that's what they're telling you. We included cross-sectional studies and cohort studies that assess the diagnostic accuracy for both PTB and rifampicin resistance, PTB alone or rifampicin resistance alone. And they also looked at RCTs that evaluated the use of the index test on outcomes, but also reported sensitivity and specificity. So not only just cross-sectional studies looking at, they even looked at RCTs, because they can take the data and the outcome between the two is like a cross-sectional study. The outcomes assessed are cross-sectional in design in terms of a person had a test or a person had not didn't have a test. And they only included studies that reported data comparing the index test to an acceptable reference standard from which they could get the data. So what you do in advance is say, I am looking for studies, the design, as well as studies which are reporting the outcomes that I want, which give you all four outcomes. Then they also look to see whether the studies in HIV positive people, irrespective of whether they have TB or not, because they're looking for a spectrum there. They may or may not have TB. So they're trying to say that, I'm looking for a wide range of studies, but the main designs are cross-sectional, cohorts, or RCTs which provide this data. Okay? So what you have to keep in mind is when we are looking at doing a systematic review, we are not doing the studies. We are looking for studies which have done things further. So you must have an idea. There may be a lot of studies out there. We are looking for these particular kind of studies. The design, what they compared, and who they were in the studies. And what will you exclude? So here they're very clear. They said we will exclude case reports and studies of the case control because of the biases in terms of spectrum, right? And also included studies of index tests in people with diabetes but without tuberculosis symptoms, and studies designed to find people with active, so community surveys and stuff they said we will not use. So they're very clear what study design you want to use. Then they looked at what kind of people, right? They're looking at adults, children with presumptive TB, rifampicin resistant tuberculosis or MDR TB. So they give you clear ideas as to what we will take, who we will not take, right? And they're looking at studies which looked at the diagnostic expert and ultra, looking at symptoms. So they're giving you clear ideas to, in the studies, if they do any of this, we will include it. Now the importance is, if you don't have a clear idea as to what you want, when you find the studies, you will have a lot of doubts. And then what usually typically happens is you look at the results of the study, and if it looks positive or looks interesting, you might include it. So you must, in the beginning it says what we will include, what we will not exclude, and somebody else should be there to ensure that you did or did not do according to your PICO. So they tell you that index tests, this is what happens with expert, so we know what the outcome here is. Detected, not detected, and indeterminate. So they tell you how they will make a decision about indeterminate. And the target condition were active PTB and rifampicin resistance, and they give you some details about the reference standards which they consider acceptable. So very detailed description of what they're going to do. And this is what they try to do in terms of search. So the databases is search were the infectious diseases group specialized register, Medline, Embase, Science Citation Index, Scopus, the LILAC, which is a Latin American database, and in their appendix, they give you the search strategy for each of these databases. So it's quite an extensive list of stuff, but nothing compared to what you will find in some other reviews where they're searching for not obvious things like expert, because gene expert is index term. You can find most of these studies if you put those terms in. They also looked at ongoing studies in terms of the clinicaltrials.gov, WHO platform, and the ISRTS and the idea is they're looking for both ongoing studies as well as studies where you can get the protocol of those studies. Because you can look at the protocol to see what people said they would do and look at what they ultimately did. So they also sought many other people from WHO and stuff. And they used a software called Covidence, which is an online software which helps you to manage references, choose studies, because multiple review authors can actually search for it. So if you're doing a review, that's a very good thing. And then they extracted data, and they give you what data they extracted. So it's good to have a form which tells you what data they extracted. This is what they extracted. And they classified studies according to low or high income. And they use a quad-as tool to make, and they also talked about what actually elements of the tool they're going to use. So there's another large section which talks about data synthesis and analysis of heterogeneity, which I'm not going to actually do right away. And assessment of certainty, this is what they say they'll do at the end when they want to summarize the evidence, that they're using the online grade development tool, Grade Pro, which helps you to do a summary of findings tables for it. And they're talking about, we rated the certainty of evidence by either downgrading it or not downgrading it. If you start down, so what happens in these studies is you assume that the evidence is good, and then you can downgrade it or not downgrade. Downgrade means our confidence is reduced for certain reasons. And what they were looking at is, if you take cross-sectional studies of the best standard study for a diagnostic test is a cross-sectional or a cohort study. So that's considered to be a high standard, right? They excluded all the case control studies and stuff. So they're taking high quality studies as far as diagnostic test accuracy, and they would have, it can downgrade by 1 or 2 levels, and they tell you how they're going to use it. So they said, if we find that in a particular forest plot or analysis, the studies were at risk of bias, then they made a decision whether that risk of bias reduces their confidence in that particular estimate, and they can downgrade it by 1 level or 2 level, depending on how serious they found that bias. Indirectness, they looked to see whether there was a difference in the spectrum of the disease, the setting, the index test outcomes, and made a decision whether this will actually lower our confidence in the results. So they, in advance, saying this is exactly what we're going to do. And they said inconsistency. So they're looking to see if there is unexplained inconsistency for the sensitivity and specificity element. And for that, what they did is they had some pre-specified analysis to look at sources of heterogeneity, whether it explains it or not. And then for imprecision, what they were asking is, you have to make a clinical decision. So looking at the width of the credible interval from all the studies, would you make a different decision if it was a lower boundary or of the upper boundary? So what I'm trying to say is that if you look at the interval of specificity and sensitivity, both the upper and the lower limits should make you feel, yes, this is useful in the clinical setting. If you find the higher sensitivity is great, but the lower sensitivity is very marginal, and you have a doubt whether it will be useful, you will say, this is not a very precise estimate, my confidence in this test is reduced. So that's not the reason to reduce it. And also they looked to see whether they had enough overall sample from an ordinary sample size calculation to make sure this is good enough. And publication bias, they looked to see whether they had done a good search, but because they thought they had done such a lot of studies, they didn't think that's going to be a big issue in this. So you have finally now, their results are in terms of a flow diagram, like you find in a consort diagram. And if you look at the final study, they've got 95 articles they've got. They describe 95 studies, out of which 70 of them were using thing in detection, and 48 of them were looking for rifampicin resistance. So they've got 2 sets of studies. One is looking for detection of TB, and the other is looking for resistance detection. They also give you a list of studies which they excluded, and the reason why they excluded it for every one of those studies. And for each study, they try and describe, I'm not going to go through 94 studies, this is one study. They say patient sampling, cross-sectional design, consecutive enrollment, prospective data collection. That's a salient feature of the design. and they look at the setting, character in the setting, where it was, which country, was it height, a Durban country or not, it's an outpatient or not, the sample size. Then they look at the tests, the index tests, and they don't have anything for flow and timing. And for each study, they do the assessment of risk of bias based on quadas. So domains, patient selection, was it random, what did you avoid the case control, and finally an overall assessment of the risk of bias and an overall assessment of applicability based on your quadas form. They do that for each of those domains. And then from that, for each of the studies in the review, the software will be able to generate for you, for each study, what were the risk of bias for each domain, for patient selection, index test, reference standard, flow and timing, and the applicability concerns as well. Okay, so you're looking at your quadas, and this is, you rate each of those studies like you did for a single study, and then you put it together, right? And then you look and see for each study. So what will help you is, suppose you got a forest plot with those sensitivity specificity plots, which of the studies are there? You can quickly look and see, is there a bias in those? It helps you to link your results with this. Okay. And the review also gives you a graph about the overall biases across these studies. Right, now I don't know if you can see, but what you got here is a forest plot of sensitivity and specificity for detecting pulmonary tuberculosis. And they've ordered it by decreasing sensitivity. So the squares are the sensitivity and specificity of one study, each side, and the confidence intervals are also there. Yeah, so if you can look at it, the confidence intervals is the line. So you'll find that some of them have got larger lines. And basically you look at each of these separately and see, do these things look consistent? So compared to this, which is more consistent? So one look at it and you will know, there seems to be consistency for the sensitivity, but less so for the specificity, particularly if you look at this one study by 52% specificity. It's a real outlier. And they couldn't explain all this. So this gives you one idea as to how you can look at your pooled sensitivities and pooled. But then you have to you can get a ROC curve. So if you look at ultra expert and stuff, you can get a curve which tells you this is ultra expert for detection of TB. It gives you a better value because that's the pooled estimate between that and this. Okay, you're comparing two. Which is better? The red or the black? Looks grey. Okay, grey. Okay, grey. Not green, no, grey. So this is better. This one, you bring it up there and you bring it down here. This one, so look at what it says, higher sensitivity 88%, confidence intervals 85 to 91, compared to 83%, 79 to 86, and lower specificity. So you can actually calculate, yeah.
So how do you generate the ROC curve?
You've got two data sets.
Individual studies.
Yeah, individual studies, the pooled values from each of the studies in the software will give you an ROC curve for each study.
Yeah.
Each study's pooled estimate. Yeah. The summary there are two. It's a multivariate analysis of it. You can even look at the difference between the sensitivities. See, 88% and 83%. What is the difference? The 5%. And you can look at this and say 96%, 83%. Sorry, 96 and 98. So you can also quantify and see what is the difference in sensitivity and specificities across these studies. So this is one of the things they do. Then you can also look and see, this one looks at detection of pulmonary tuberculosis, HIV negative and positive, looking at expert TB. And you can look at the pooled sensitivity, there's no pooled sensitivity, you look at the overall sensitivity here and here. This is within study comparison, HIV negative and HIV positive within study. That means in the study they've done the things themselves. Right? So you're not taking studies which are done HIV, you didn't do it HIV. The study themselves are comparing HIV negative, HIV positive, sensitivity, specificity of HIV ultra. And if you want to look at that way, then this is expert MTB compared to for detection of HIV negative and HIV positive. So the plots for HIV negative are in red and for HIV positive are in black. Okay, so each study is represented by an empty square. The square is proportional to the sample size of the study, so the larger studies are, so this study's got a big square, that's a large study. Okay, the filled circle is a pooled median estimate for sensitivity and specificity, and the solid curve is a credible region around the sensitivities. Okay, so if you look at that, what it then tells you is that the red is what?
HIV negative.
This is HIV negative and HIV positive. So what you can then do is compare these two to see this one study and the credible interval and that one study and the credible interval. And that's the projected, that is the way of looking at heterogeneity in this. So when you have this kind of summary plot, which are looking binomial plot, you have the pooled sensitivity. There are numerical values for it, I don't have that here, but that one and this one differ. This one shows basically it is more sensitive in which HIV negative people. So it tells you, you can compare and see which one, in which of the groups of people is the test more negative. Okay. There are many other ways you can do analysis, but I'm just giving you an idea of which ones. Then you finally summarize the results. So this is what goes into a summary of findings table. It talks about expert and ultra for detection TB. What is the diagnostic accuracy, and give you what the population are in the studies. What is they're saying the role is as an initial test. The index test is the expert. The threshold for index test is an automatic result. The reference standard where they're comparing, this is all solid and liquid culture. They've compared that. And the studies were cross-sectional cohort studies taken from primary care facilities. So it gives you an idea of what was compared and where what was done. And they're giving you the index test, expert in unselected participants, the pooled sensitivity is 85% and the 95% credible interval is 82 to 88 for expert. In this group, and in this group it is different. If a pooled specificity is 98, 97 to 98. It tells you number of studies and participants. It also gives you the 2x2 table of prevalence at 1% prevalence, at 10% prevalence, at 30% prevalence. So they're able to, from their data, give you this estimates of positives and negatives from all of these. And they're saying that the confidence they have that these are the estimates is high. For ultra, they're able to give you these, what these things are. So from this, actually, if you want, you can actually calculate your likelihood ratios from your positive and negative tests. So when you say that this is high and low, what exactly do you mean here? They've given you footnotes for that. So it says A, B, and C. Now they're saying the median tuberculosis prevalence in the studies was 26%, and thus the results tend to be more applicable to settings with the high tuberculosis prevalence. But tuberculosis prevalence of 1% and 10%, whether or not to downgrade the studies is unclear. It is possible that tests will perform differently at lower tuberculosis prevalence threshold, but we did not downgrade this for indirectness because of the prevalence of the different. They said overall we think it's okay. If you've got a very low tuberculosis prevalence, it might not give you the same results, but you're not going to use this. You're actually going to use it in high income settings, in high transmission settings. So they made a judgment that we're not going to downgrade it for indirectness in terms of the fact that the prevalence across studies differ. Now the next one, for individual studies, sensitivity estimates range from 43% to 100%. We thought that differences in enrollment criteria, disease severity setting could explain heterogeneity. So they had done tests to see whether these things actually explain it, and because it seemed to explain it, they did not downgrade for inconsistency. We can understand why there is some inconsistency. Then the third one, there were a large number of studies and participant analysis. The 95% credible interval around true positives and false negatives will probably not lead to different decisions depending on which credible limits are assumed. That means the upper, lower end of sensitivity specificities are not going to change my decision on how useful the test is. Because if you go back and look at your pooled sensitivities 82 to 88, specificity is 97 to 98. So whether it is 82 to or 88, it won't make a difference to whether you use it. It's not so wide, right? Here, it says it's 98, but the interval is 97 to 98. Whether it's 97 or 98, you're not going to make a difference. So they're saying that's not changing my... So we're not downgrading this for inconsistency, for imprecision. But for this, they said the tuberculosis prevalence, that is in the D. What is D? D is this one, right? There's only one study. Okay, so they give you a separate thing. They said the tuberculosis prevalence in the study was 32%, and thus the results tend to be more applicable to settings with a high tuberculosis prevalence. For tuberculosis prevalence of 1% and 10%, we were not clear. No, sorry, the other one, this is one. Although there was only one study on the accuracy of expert ultra for PTB, this was a multi-centered study conducted in 8 countries, and they downgraded by 1 level for imprecision. What do you mean by imprecision here? 95%, at 90 and 98. So they felt for sensitivity in high prevalence setting, if it is 95%, this is a very good test, right? But at 90%, they're not very happy with that sensitivity, okay? Here, specificity is 98%, 97 to 90. They're not worried about the specificity. They are not very happy about the sensitivity of this test in picking up tuberculosis. So that for that reason, they downgraded by 1 level. So I am now, this is another thing, expert MTB and expert ultra for detection of rifampicin resistance. Okay, so here they're looking at the comparison of the two studies, and when you compare the two, they have a reference standard based on that. The pooled, this is expert MTB, pooled sensitivity is 96, 94 to 97, again high quality evidence. Specificity is 98 to 99%, high quality evidence. So this is how they organize these tables, right? And finally, the decision for them is that expert is a good thing that you can use because the evidence seems to suggest it, but it seems to perform better in HIV negative people.